Hello, hello. Welcome to the stream. It's been a while since I've been back. How did I get another point on... Well, that's interesting. I didn't even play again. Here, I'll just do it again. Drop. Have to remember how to even play my own game. All right. I am super happy to be back. It's been a great month. Where I was able to take some time, sort of like think about what my plan was. Also, at the same time, I was taking the creative engineering course with Mark Rober. Now, that's not a course where I was like actually interacting like one-on-one any times with Mark Rober, but rather it was a sort of like a monthly course that he created, with a bunch of videos and a bunch of lessons and project builds. I ended up creating 3 things, and I shared those out with in Discord. So if you want to join that, you can. Those videos are still actually there. You can go take a look at them, see what I built, and I'm planning on actually continuing to lean into that. I really like the idea of like the physical builds. I especially like the idea of it being a hobby that I can do that takes me away from staring at a screen. Now I did find that there is a minor problem with doing these physical builds. Now, I'm not thinking of like only woodworking, for example. I'm thinking about doing things with like Arduinos and motors and some other fun stuff. And yeah, there's a little bit of screen time for that, but a lot of it is like putting it together. And Zilby loves the tiny wires that I was using with the Arduinos, to the point where I would like start taking them out, putting them onto the table. He would run into the room, jump up, try to sneakily grab one without me watching, so he could tear out of the room and go and like, I don't know, probably swallow it and end up needing to go to the pet emergency room. So I ended up having to lock him out of the room every time I was doing that. Every time I was working on the projects, and then put them all back away into the closet, like store everything away, put it back into the closet, clear everything out, even the project itself, because also he likes to chew on nails. Not the best thing to do. So if I want to like actually work on that, I'm gonna need some kind of workbench that I can store someplace where Zilby will never go. And down here in the basement isn't a good idea, because I want Zilby to be able to come in here, hang out with us while we're streaming. My office, not like I want him to be able to come into my office. So I'm thinking about taking some of the space in the garage that I have, clearing that array of all the junk that I've got, and then building a workbench. And I actually found a tutorial on that. I haven't decided if I'm going to build a workbench or if I'm going to buy one. Turns out they're about the same cost. But one I would like, I'm not sure if like the one I would build myself would be higher quality or lower quality. Or if it would like, maybe it would just be the teaching, like, you know, the teachable moments, and I would like learn a lot more by doing that. I'm not exactly sure yet. So I'll have to think about what I want from that. So I am planning on doing those as like sort of like my side hobby, because this is also a side hobby too. That's probably going to be the thing I do after work. Before work is going to be this, and on Sundays. And who knows, maybe one day I'll even be able to stream some of that if I ever get like the camera stuff over there and like figure out how to extend the internet all the way to the garage. All right. That's not what today is about. Today, I want to start working towards the Pitfall game again, because I do want to build it, and I've got until August, end of July, to get that done. Now I don't want to just like work on it straight for like, you know, that amount of time. I want to improve my skills, get myself to the point where I can quickly create these type of games, maybe even be able to build multiple games that I can throw onto a Raspberry Pi and ship it out as part of like a console. I think that would be a lot of fun. So the first part about that is going to be ECS. I want to implement my own ECS system. The reason for that is I've used SPECS before in the past, and SPECS is a really great ECS system. I've actually seen some companies are using it in the wild, so it's a professional grade, whatever that means. But I want to actually like get a little bit better understanding of what's going on behind the scenes. So that way, when I go back and I use SPECS, maybe I can use it a little bit better. And I've also, I Am Hardliner, I think, introduced me to HECS, HECS, which is another entity component system for Rust. And it uses, it's a much simpler thing. I think I'm going to be going towards more of the hex style than the spec style for my own. But when thinking about this, I came up with like these 3 different ways that I can store our entities. Chantilly, hello. How are you doing? How have you been? It's been a long time. So we have 3 different ideas of like how I could possibly store the entities in some kind of vector. So what do I mean by this? Let's come with the differences. Oh yeah, so the differences here. Good. That's awesome to hear. So dynamic dispatch is okay. So Rust is a compiled language, meaning that a lot of the checks and the compiler can do a lot of really cool things to speed up the program, have it take, maybe even a little bit less memory at compile time. Dynamic dispatch, however, is basically saying, yeah, but I want a bunch of my stuff to happen at runtime, not at compile time. So what I can basically say is, instead of doing a lot of type checking now, do it later. Do it when I'm running. So that's what dynamic dispatch is basically it allows me to do the equivalent of like the Lispoff. Is that it? Lispoff? Oh man, I forgot the L in solid. But it's a substitution principle where I can basically say, I have this looking like, I have this structure, I have this object, and it kind of looks like this other object. So therefore, at runtime, I don't really care which one I get. I want to be able to handle any of them. So that would be dynamic dispatch, where I can hand it a, like, I don't know, a number, a different type of number, a string. It would just all be able to handle that. And that's the idea, because like I have a location. So let's say I have a location here, and the location is like an X of 35.38 and a Y of 98.2. So if I have something like that, but I also have a, like, I don't know, type is, maybe this is going to be a string, which is going to be like a player. Let's see. Chantilly, what's the difference between hex and spec? Okay, it's hex as in, here, let me actually just show you. Create.io. So there's hex, which is this one. It's a high performance, minimalistic entity component system. Basically, it's a super basic ECS system. And then SPECS is, it just is an entity component system. It's actually more fully featured entity component system. And we can actually see the size here. It's 124 kilobytes versus 42.2. So very small. Ergazia, hello. What's the utility of square brackets? What can you put within? Oh, are you talking about within the markdown file? So this is a markdown file. What I can do inside of here. Let me show you the preview. Oh, it doesn't show the preview properly here. I think in GitHub it shows the preview properly. Oh man, okay, fine. So normally in GitHub, when you do this and you have the open brackets, it's a checkbox. And I can put an X inside of it to denote that it's checked. So it's a nice, easy way to like denote checkboxes in Markdown. I have to put the space in. If you don't put the space in, it doesn't work properly. Maybe that's the problem here in preview, because in GitHub it wants it to be spaces. No, doesn't care here either. But it's not a Rust thing. This is a Markdown file. So I was looking at Hex, and it uses dynamic dispatch, and I believe I looked at SPECS too a little bit. It's a lot more complex to sort of like dig through the source code to figure out exactly how they're storing things. It's a combination of generics and dynamic dispatch is what it looks like. Now in enum, I read an article that was posted on Reddit a while ago, and I lost the link, unfortunately. This was like last year. That was talking about generics. You could get around dynamic dispatch and generics by using enums for your types. But there's some inherent problems with enums. Especially if I'm planning on having this be a library that I send, I'm going to actually publish this to crates.io. It's not really meant for anybody else to use it, but it's going to make it really easy for me to pull into like all of my projects. If I use an enum, that's going to be shared across all of my projects. So I lose a lot of like custom types that I can do, because all the possible types will have to be stored inside of BB ECS, which is, for my projects, it's not the worst thing in the world, but it does mean that BB ECS now has to be aware of all my other projects and how they work, which is actually a big no-no when it comes to architecture. So that is a pretty big negative, but I want to like show what that looks like anyways. So let's do, let's see, maybe enums would be the simplest to start with. So let's actually, here I have in BB ECS, I have, and I don't know if I want to start here or it might be easier. Maybe I'll just go to play Rust here. And we'll do some of our testing here. Hopefully this is large enough for us. So what I want to have is I want to have like a struct world, and I want to store the entities in some kind of like, probably it's going to be like a hash map. But we can imagine that, yeah, it would almost definitely have to be a hash map, because I would have to show, okay, well, you know what? I realized I don't think I've described like ECS and like what that means. This is actually kind of fun. So ECS is where you're structuring your data to be in horizontal columns as opposed to individual objects. So I might normally have something like a struct. Let's say we're creating, I'm creating a flocking simulation. So a flocking simulation is like a bunch of birds flocking together and like flying around the screen. So I might have like a bird, and the bird might have a position. Let's just actually say it has like an X, which is an F32. It has a Y, which is an F32. Maybe it has a, like a speed or like a velocity X, which is an F32, a velocity Y, which is an F32. And it would also have to have like a sphere of influence, like where, like how far it's looking around itself. So awareness or something. Awareness radius, which is also an F32. A lot of these are F32s here. So I then spin up like 1,000 birds to put onto the screen, and I create 1,000 of these components, and maybe I store that, and I could say let birds, which is going to be a vector of bird, equals vec new, something like that. And then I can throw a new bird in here. So birds.push, you're gonna have to be immutable. And we'll bring in a new bird. So it's like X is, we'll just start like in the upper left corner. So Y 0, maybe have a velocity X, velocity X of like 15.0, velocity Y of 15.0, and awareness radius of 25. So this would like add in this new bird, and I can copy this as many times as I want to add in more and more and more birds. There is a problem with this. Structs like put all of their data together into memory. That's fine, like that's great, except I don't really care about the awareness at the same time that I care about the X or the Y. Oftentimes what I'm doing is I'm updating all of the locations of the birds, like just going through all the birds, update their locations, then go through all the birds and update their velocities, go through all the birds and update their change their directions. And that means when I load up a bird into memory, I'm ignoring like maybe their awareness radius. If there's other data in here, like let's say I have like a life in here, I'm going to ignore that most of the time. So ECS changes the way I store these from, instead of having like a struct bird, now I'll have a struct entity. And this is where it gets a little bit interesting, because inside of here, I might have something like data, and that's something, we're in a strongly typed world here, so it has to be something specific. So if I go with enums, and then that way I will have down here, let locations, let's say, equals a new vector. And so let's say I have like 3 birds. So maybe I'll store these in like a tuple for like the X and the Y. So let's just do this location like this. This will be easier. X is an F32 and Y is an F32. So then we can have, I want a location. X is 0.0, Y is 0.0. Let's say I just copy this a few times. And now, maybe you're 5, 0, and you're 10, 0. So just starting in a row all at the top. Okay, so this is locations. So I just have a vector of locations, and that's it. And then I would have a vector of velocities, and then a vector of awareness radiuses. So the data is now stored in a vector. And this is really cool because when the CPU goes to get memory, and I say, hey, I want to get the location here, it loads this first one, but because of like caching reasons, it's not just going to load this first one. It's going to load a little bit around it. So maybe the first 3 or the first 5. It really depends upon the cache that you have. And that means I can go through all of these down, update the location, and then just immediately update this location and then this location. And it's faster because I'm not getting what's called a cache miss. I'm not having to reload from memory, which ironically is really slow compared to what the CPU can do. So that's the benefit of ECS systems. The negative is that storing things in this way is not intuitive. So it takes a little bit of extra effort mentally for us to sort of get these in a way. So let's say I have like locations and I want to store them. Okay, so here's like a location. You're fine with this. If I want to do like Hex, I notice really care, like just stores everything in tuples, like just pass everything as a tuple, and that's fine. We're probably gonna want an entity. So struct entity. We'll have like the data inside of it. We might have some other things inside of here. We need something to go in here to tell it the type of it, and we need it to be consistent. So if I were to choose some kind of what's the first one, an enum for this? Well, maybe instead of a struct location like that, we could have enum. This is gonna be like entity data. This allows me to now set that the type that's coming in here is entity data. Because of that, if I have my locations just set up here, now I can say that you're all just going to be entity, then like just create that. Just add, add it in. It's all good. Maybe in here we'll do a impl entity. And let's see, what would that look like? Impl entity, we want a pub function. Let's create a new function for this. We're gonna take in an entity data. And we're gonna return a self, capital S for this. And in Rust, if you do a capital S, self, that's actually the full entity, not the instance of the entity. And then we're going to return a self data like that. No saving for this. We're in the web, so that's fine. So let's say I want to store like all these locations. I would create an entity new, well, the first bird's location, Raven Legend, hello. Oh, and you asked the technical questions to say hello. I'll redeem that. Okay, so entity new. We need to give it this entity data. So let's add in here a location. And then I'm going to make this an anonymous struct that has an X, which is an F32, and a Y, which is an F32. And so if I do that, now entity new, this can be an entity data, colon, location, and then we'll put X of like 0.0, Y of 0.0. And so this works. Like this is going to be fine. It's now abstracted into this entity data, so I can have multiple types in here. It's like location just happens to be a struct with like an X and a Y in it. But then this other one, velocity X, velocity Y, would probably also have an X and a Y, but awareness radius wouldn't. Awareness radius would be this would have to be a tuple of like F32 of just like a single number like that. And so then I would want to then do let awareness radius is equal to a vec entity new entity data. And then that's going to be awareness radius of like 25. And that's also legal. I keep on hitting save by accident. I don't even think we have a bird anymore, so this code won't work anymore. And then I would potentially use a hash map to store all of these vectors together. So that way when I say, okay, I want to loop through all of the locations, I'm just looping through all of the vectors that I really care about. Like, so I want the locations and the velocities together, and then I'm going to update them. Raven Legend, you redeemed the cat. Unfortunately, Zilby isn't down here right now. I don't see him down here. Maybe he'll make an appearance. I'll keep that request on standby just in case he comes, and then we'll pet the cat. And then also, you asked, how is the course? Yeah, so if you just came in, I took the Creative Engineering with Mark Rober course that he announced on YouTube, like, I don't know, December sometime. So anyways, I thought it was pretty good. Now I did take it at the reduced cost because I got the early bird, and also it was like the first one he was doing. And I created three builds, and I put the videos for those on my Discord. If you want to go and join that, sort of like look at those. I don't know if the bot is up actually. Oh, the bot's not up, so I can't do Discord like that. Let me actually fix that. Actually, I can't fix that really easily right now. I will just get an invite link. There. That's an invite link for that, in case you want to go and join that and see those videos. But yeah, like I created a physical build, like I drop bottles into it and I can like turn them out. That's for like supplements that I have to take ever since I got my concussion a couple years ago. Let's see, my second one was I created a lightning photo and had like little LEDs in them with an Arduino controlling it to like actually flash the lightning. That was a lot of fun. And then my final one was I created a like I'm not exactly sure what to call it. It's not like a pachinko machine, but basically I had like a wooden board. I nailed a bunch of nails into it, and I'm able to drop balls in, and I was trying to make it so it automatically determine which bay it went into, and then I can like have like a point scoring thing move over as it hit there. The sensors I got didn't really work with the ping pong balls too well, so I had to like press buttons to get that to work, but it mostly works. It's given me some really interesting ideas that I want to try for this for the stream. Like I can make a physical drop game. That would be a lot of fun. That'll be later though. I won't be building that on stream, at least in the short term, for a while. Maybe after I get a workbench set up and protect it from Zilby, then that'll be fine. All right, back to this. So this is the general idea for using enums for this. So if I want to take this, we have this enum entity data, we have the struct. Now the problem is that like we see that I have this awareness radius here. You like the lightning art? Yeah, that was a lot of fun. I wish I had like sound effects for it too. That would be really cool, but I didn't have any good speakers. So the awareness radius is like really telling me that this this library would have to be extremely aware of what types are necessary for for everything. Like awareness radius is not something that's going to be inside of like a Pong game or Pitfall or Asteroids It's only something localized to the flocking simulation as far as I know. So I really don't like the idea of enums just because of that. That being said, this would be the fastest. Well, no, that's not true. This would be maybe compile time the fastest to compile and the fastest to run. Generics would also be the fastest to run, but slower to compile. And dynamic dispatch would be fastest to compile and slowest to run. Okay, so this is a negative. I don't like it because of this. But I think I can get this to compile. Yeah, we have warnings because we're not using them, but I could do something like I could have these be mutable. If I created really quickly let's do the velocity. We'll do a velocity. You're also F32. Y is F32. And you're essentially this. I can't use the same shortcut keys as VS Code. We'll do velocities. And ooh, first try and new score. Awesome. Okay, so we have velocities, and then let's say this is like 15 and 15. So we would expect if we add them together after one tick, the locations would then be 15, 15. So the way I would use this would be I would take all of these vectors and I would loop through them. I would also want to make sure they're the same length. Specs makes it so you don't have to have them the same length. However, I am probably gonna have, I think Hex also does that. For mine, I think I'm gonna require them to be the same length, so there'll just be some nones and options there. It'll be interesting. Okay, so if I want to go through this, we have locations and velocities. I want to loop through. I only care about the locations and velocities. So we're going to do a for. We can actually figure out what like the length of this is going to be. So for 0, let's see, what is the variable? It's going to be like the index in 0 ... Just do locations dot length. Then for each of these, we want to get the current location so that we could store them in a vector, but it doesn't really matter. We do need to make sure that these are mutable. They are right here. So I can just say, so like location of position index, it's mutable. So I can update this. So .x, I want to plus equal you to velocities of index .x, and then we'll do the exact same thing for the y. And then after this runs, let's go ahead and print line. Oh, I forgot the print macro. I think that's it, right? We wanted to print. Oh, actually, you know what? We could just debug. Debug, it's a macro, and we're going to pass it locations. And that's all I care about. No saving. Then let's run this. Can I find location in a scope? Right, because it's locations. What's your opinion on articles saying Rust is going to eventually replace Python? I don't believe that. I guess I just can't believe that Rust is going to replace Python completely. If we take a look at like the history of like languages coming in that are replacing other languages, it's so rare to see that happen. Like we thought that like C# was going to replace Java. Not even close. People thought that Python would kill Ruby. No, not even close. People thought Ruby was going to kill Python. Not even close. Even Perl is still around and still being updated and used. PHP is growing, is like you're gaining share again. I don't really buy that like any one language can kill another language completely. It can eat some of its market share, but yeah, I don't think so. I think that there's gonna be some scientific community switching over to Rust, but I still think plenty are gonna stay with Python. You don't have to spend as much time training your scientists on how to write Rust code if they're using Python. It'll just be faster. So that'll be a huge win for them. Kotu Fan, I remember back when Java was going to replace C++ and then C# would replace Java. It never happens. Python never replaced PHP either. Exactly. It's just never. That being said, what it really means is there's more tools to use. And if you work for like a great company that allows the development team to choose the tools that you use instead of like the CEO saying, hey, by the way, I read this really cool thing saying that Python is the way to go for anything data science, you could then say, hey, you know what? This Rust thing is pretty amazing for like runtime, and our unique problem set is solved by Rust's ecosystem. Therefore, we should use it. That's like it might replace it in your company. That's all I'm trying to say there. All right, no field X and type entity. All right, so the problem here is it's not as easy. I can't just go through and do this because it doesn't actually know the locations of index is entity, well, is an entity which has data in it. Okay, so that's fine. So we're actually, this is going to be a little bit more difficult than what I was initially thinking. If we have an entity in here, and right now I'm getting, I can't remember. I think I'm just getting a reference to this. I might be getting a mutable reference. What I want to get is inside of entity data, I'm in entity, so I need to get into the data, but then I need to match based upon what this is. So that's a little bit difficult. So we can see that this is like not the best, because I'm gonna need to match on both of these. Ugh, that's kind of sucky now. Okay, so I need you to be location and velocity. Great. So we're just entity. We need to get out the self. We need to get out the data. So let's like break this down. So we'll just do entity is equal to locations index dot data. Okay, so that gives me the entity. I need you to be mutable. Great. Okay. So then I have the data. I need a match on that data to make sure like which one of these it is. Well, this is fun. Okay, so we have our entity. This is just the locations. This is really a location. I can't remember if I can test an arm. I guess I could use matches. So if matches we can say location is equal to entity data, except I don't know how to say like that is one of these, because that's a little bit nasty. So I don't think I can use matches either. I think I have to use match. So we're gonna match on location. The only one I care about here is entity data location. Location, and then we're gonna extract out the X and the Y. We should probably, well, it'll be fine. X and a Y here. And then we can run our code. Like this. So now we have our entity data, we have our location, which now we can update, but we now need to loop through the velocities to extract the velocity out, do another match, because in here we're gonna say, okay, well, if you're literally anything else, we don't, like, we don't care about that. Oh God, this is terrible. We don't want this. This is not the way for us to go. You can see that there's going to be a lot of code to work with the enum. In the end, it'll make it like really fast, but there's so much code here. It's completely useless for us. The problem with letting devs choose their tools, 10 years later, we have 3 Go apps, 3 Python apps, 5 C# apps, and a bunch of stuff written in Pascal that no one is ever willing to touch because it breaks so easily. It's just a mess to maintain and support. Devs come and go, the technology tends to stick around for decades. I agree with that also. So like in my mind, the answer is like the teams need to own, like the teams, not the developers, own the decisions about what technologies to use. So if there's like a super good choice to go with like Go for something, then the team can discuss it and then make the decision to go with it. But then that can't just be like in isolation of like, hey, I really wanted to learn Go, so I just built the thing in Go. It's more of like, it's actually like this. You come down and you write down all your choices. Exactly like this. You do some experimentation. What's the best choice for us right now? What are the trade-offs? So like we see here in enum is fast compile time, types are easy to use, but a lot of extra like a lot of extra code to handle the enums. And then I find, you know what? Enums are clearly not the way to go. So we'll mark it off that we've looked at it. I wonder, can I do that? I don't know if that's a thing in Markdown. No, I don't think it is. I don't know how to do a strike through. It'd be nice. But we can just say like, hey, we're not going to use this. We're not going to use it. Okay, so that leaves dynamic dispatch and generics. Sure Shock, hello. Oh, sometimes you need spaces around the X. Yeah, I don't want to like mark that I'm choosing this one though. That's like, I want to like say like, oh, I'm not choosing it. Which, yeah, that gets a little bit interesting. I'm really curious. If I do that, do you work? No, that still doesn't work. And neither does that. Preview, Markdown preview on VS Code is not very good. Maybe if I like told it that it was like GitHub style Markdown, maybe it would work a little bit better. All right. So, it works on GitHub. It definitely works on GitHub. It absolutely does. Ooh, Strike through is double. Okay, let's try this. Double. Double. Yes. Okay, that works. Thank you, Kotu-fan and Chantilly, for that. So now what I could do is I could mark this as a checkbox and we'll mark it as checked, even though this one doesn't really do that properly, but now we can denote we're not going to use it. It's not there. Okay, so generics is the next thing. So at this point in time, I think I might be switching from using the playground to just like actual code and VS Code, because it can actually, I think I need the help of the Rust analyzer for like figuring out where I'm making mistakes with like using generic stuff, because I'm not very used to doing that. So here we are with our library. Maybe I can actually do a test here. We'll hijack this test, sort of like figure out how this is going to work. So I want to be able to store in the world all the different types of entities. So that means I need a struct pub struct entity that's going to have a data of something. So most people use like T for that. Now we don't know what this T is. We know like currently we care mostly about like just F32s. Like that's the only thing we care about. Okay, so if I do that, I need to also initialize the T. So you can see here, can I find type T in this scope? I'm missing a type parameter. I think that's up here where I can then do curly bracket. No. Yeah, that T. Like that. So I initialize the T. And here it is. Okay, so it's happy again. And then I can, thank you, SureShock. I can then in here say something like, okay, I want to store something in T. Store something in entity. So we can do let like maybe like location is equal to entity data of like 25.0 F32. So just to tell it specifically, that's an F32. Can I find struct? Okay, use super start. Well, that works. And so let's say I also want to like store something else, like not an F32. What are the types of things that like I might actually have and care about? Maybe I have a U32 that I care about. So like let maybe I have like I don't know, it's like index is position. We can do a type of a string. Maybe that will work. Let's try that. So we can do like a type equals entity data of a string. It's gonna be like a player. See, are you happy? We can't be type. So this is gonna be like entity types. Okay, still works there. So you notice that this generics are able to like store different types of things, which now means I can take this location entity type and I can say let entities, which is going to be a type vec of entity equal to a vec of location and entity type. Now that's not how I would actually store it in ECS, but it's showing, well, okay, problem. Wrong number of type arguments, expected 1, found 0. So there's an issue. it needs to know what type this is going to be. So what if I have this be a type T? Like that. So can I find T in this scope? So now I need to tell that this function has a T. No, I can't. Yeah. Oh, vec T, which T? Oh, it's the other way around. So vec T like that. But then entity needs that. So like we run into a problem with generics really quickly. Now we could basically, if we have like I was correct. It would be entity like that with T inside, except T now I need to have you be, oh, is it here or is it the other side? Oh, it's not there. Where do I put it? Actually, I don't know if functions can handle it. Can functions have generics inside of them? I think it's inside of structs only. Oh, it's on the other side of the parentheses here. Okay. Type annotations need can infer type for a type parameter T declared on a function. It works. Okay. So now I need to tell cannot infer type for a parameter. It can't figure out what T is supposed to be. I have to give it some like limitations. I think I can do something like colon and then give it that limitation. Or there's a where statement I can do too. This is where my knowledge about generics breaks down a little bit. And like what I can actually do with it and like how strong it is, because I haven't actually used generics for anything real yet. So if I say something like it's a trait, I would give it like a trait that strings like strs and F32s both have. Like what the heck is that? So I know that I can do core any, but it still can't infer the type. That's not specific enough, I guess. So that's a problem. Now that being said, I don't think I would store it like exactly like this. I think we would have to have something like a pub struct world. We'd have entity. Our world is going to be made up of vectors of things. So let's actually think about how we're really going to do this for real, because I think I might actually cause myself to think that generics wouldn't work by just doing them incorrectly here. So let's actually figure this out. Yeah, it works would never know what T is. Yeah, I could see that being a problem, obviously. So let's say I want to create a bird. What is a bird? A bird, it has, well, we figured out what that is. A bird has a location, it has a velocity, and it has like awareness radius. So those are three types of components that we need to add into our world. Well, I can use the enum, but I want this to be a separately deployable ECS system and use something else. I can use the enum. Let's see, pub struct A, pub struct B, enum either A, B, B, function. Let's mean let mute V equals vector, either A, either BB. Right, but then I think I run into the problem where the enum has to be too aware. Is that correct? Or can I use generics and enums? I don't think I've thought about that before. if the enum could have a generic in it, that could be interesting. But okay, so let's say I want to like register components. So I will want to do something like, okay, like we're gonna create the world. So that world, this is probably got to be mutable. So let's see. Creating the world. Enums can have generics, but you'll get the same problem. Yeah. And it's like, that's the one thing, the one problem about enums that I'm running into here is I don't want them to be so specific to one simulation or game that I'm doing. And enums are great if it's within the same program, but because it's a generic library, or I want it to be a library that can handle different games or simulations, I don't want the enums to be too specific. That being said, if I have to, it is just a library for all of my games. So it's not the worst thing in the world, but I think that there are places to go for it. I think. You can do one thing if you want to accept all type vec, dyn, any. Right, and that's where we're talking about the three different choices here: dynamic dispatch, generics, or enums. I'm guessing we're going to end up with dynamic dispatch, but we'll see. Okay, so if we created a world, let's do a world. Right now you're empty like that. I almost always like to just create like a new function on here. That will just like initialize the world, then I can do a little bit. I only have to change it in like one place to sort of like update this. Okay, so we create a new world. We'll impl world, a function new, and return a self. All right, so world, actually this is just self, like that. Okay, so that gives us a new world. Now I want to register a new component for for this system. That's going to be the location. And let's say that the location is just a tuple of like X and Y. So if I do something like I want to create the bird, so create a bird, we will have like it's XY location. So that location is equal to, maybe this could be a tuple of like 0.0 and 0.0, X and Y there. I want you to be a tuple of F32, F32. So that way I'm just specific so that the tests will update properly for me as I go through this. Okay. I want to register this into world as part of like its components. So if I have this just be aware, like I need to register locations as a component. That means it has to be a vector of some kind. And like what it's going to store in is maybe this entity data. Okay. Let's see. So if I don't store the location right now, I need to register the world. So we're going to say world dot like register component. And I want this to be like a location. Something like that. That would maybe add into a hash map that we're going to have location, and it's going to create a vector of entity. Okay. So here we're going to have components, and we're going to have a hash map. Now the type, I'm thinking static stirs. So just a stir. And then an entity. Can I do this, the static? No, I can't do that there. I don't think I need to do like an A, like give it a lifetime specifically for this. Can I just do stir like that? Entity, wrong number of type arguments, expected 1. Okay, so entity, whatever this is, like I don't know what that is. So this is probably going to be T. So now we have to store that there. Okay, so you're happy again. Okay, so when we're creating this, we need to create a new hash map. So we'll have components is a hash map. New. Okay, so that makes you happy. And now we're expecting, type arguments here. So I think it's here. T like that. And T like that. Okay, the size for values stir. I could just have this be a full string. That might make sense for us. That certainly makes everything compile. That's probably the easiest. Is just to say, you know what, you need to be a like 2-owned. Like we're just gonna pass this in. Actually, you know what's easiest here is instead of doing 2-owned, we'll do register component. That'll be another function here. So pub function, register component. We'll take in a mutable reference to self, and we'll also take in a this like the name, and we're saying that this is a reference to a stir, so a stir. And we don't have to return anything, but what we're going to do is we're going to initialize an empty vector inside of components here. So we're going to say self, go back down here, self.components dot insert. Our key is going to be the name dot toOwned. And the value is going to be an empty vector. Show me the error. Come on. I have to like not. Okay, mismatch typed, expected, struct. Oh, entity. It's not an empty vector like this. I don't want this to be an entity like that. I want you to be a vector with entity like that. Now you're probably going to have a T to have you be happy. Okay, so name and then in you, an empty vector there. Okay, we're happy so far. So we create a new world. Type annotations needed for world. So this is where we're starting to run into trouble here. I'm in this function and I don't know what types to give it. I could give it like its type entity, but that's not really helpful. Like the entire point of using generics here is that I don't need to care about that. So this isn't really helpful. So cannot infer type for type parameter T. Consider giving world the explicit type world T, where the type parameter T is specified. So I could do something like world, where does it want me to do that? World like F32. I could do that. And that would work, except as soon as I don't have an F32 inside of here. So that's a problem. Now, I wonder if I can get away with this if I say that I want this T. Do I do a where here? Never remember where I do wheres. Where T is like an F32. No, it's a trait. An F32 isn't a trait itself. The trait might be like clone, where it implements clone. I don't think I did that right. Oh, I just do it like that. Oh, hello! Zilby's coming and joining. Zilby. We can have a pet the cat. Zilby obviously has grown a little bit since the last time we were on stream. I did post some pictures of Zilby over the last month or two in the Discord, and I'll continue to do that. He's around half a year old now. Maybe a little bit older. It's a little bit hard to tell because he's a rescue kitten and we don't know his exact birth date. Are you done? You want to explore again? All right. Well, we got a little bit of pet the cat. Okay, so we're basically running into, let's see. What if I do this as, so I found there's this core any trait, and a lot of like the default traits, like a lot of the base types have that. But the problem here now is the parameter T may not live long enough so that the type T will meet its required lifetime bounds. Oh, so now do we need to give it lifetime stuff? I want to avoid like setting lifetimes if I can. Okay, so consider adding an explicit lifetime bound. So, I mean, I guess I could try. Where do I put that? It's been forever since I've dealt with like lifetimes. I think, is that also here where I can have like, so like A. Like that. No, it really doesn't like that. Expected comma. Okay, well. Oh, maybe I can I give that like a, no, I can't do that. Don't put that there. Let's see, where do I put it? That's, okay, so this is, I think that's happy down there. Expected one of constant over a lifetime. I don't think I have to do something like this. Like a double declaration, so that's not happy. I think I have to go look it up. Lifetime Rust struct. Where's the settings for this? Oh, I can't make this dark mode? I'm used to like settings on the books being like up near the top, but I don't see anything. Okay, so lifetimes. It's like a. Okay, so like function bar. Ah, okay, so just A like that. Oh, I think. It's not like that. Ah, I think, okay, that's what it is. So T, comma, the A lifetime like U. Lifetime parameters must be declared prior to type parameters. Okay, so it would be the opposite. That and like that. And then the type, lifetime of T does not fulfill the required lifetime type, must satisfy. Okay, hold on. Can you then be like that? No, you're not happy with that. So I need to give it a specific lifetime bound. I don't want, like, I want T to be owned, so I don't want to say that it's like a reference. I don't think I can do something like that. Wrong number of lifetime references, expected 0, found 1. Well, wait a second. You told me I need a lifetime argument, and now you're telling me I don't. Where do I need to put the lifetime argument? On what? The parameter type T may not live long enough. Let me actually run this for real and get the error code. So, yes. Zippy's trying to get into the closet that we don't want him to get into. Okay, so indicate the anonymous lifetime. Oh, okay, so I can do input roll T, give it an anonymous lifetime like that, is what it suggests. Okay, so on line 14. Ah, okay, so I need to add it here too. So can I just do that? And then do that. No, okay, so you need to be a named lifetime. All right, what's next? Okay, so that type T will meet its required lifetime bounds. Consider adding an explicit lifetime bound T : static. Okay, that's up here. So I want a bound off of this T, and I think that's where the where comes in. So if I do something like static, expected comma, do I need a where outside of this? Where T, comma, oh, okay, hold on, I had that wrong then. Static. Parameter A is never used. Okay, so do I need you then at all? No, okay, so we're telling you that you're static. Okay, thank you, Moonshell, for that. Yeah, it shows that like my lack of like experience with generics. I keep on forgetting like the syntax for them. Okay, so we now telling it that T has to be static. Maybe like we'll see how well that ends up working. Okay, so now type annotations needed for this. That's a problem still. What are the types for world? Like, I don't think I can say your C Films, hello. I don't think I can say like new. Okay, so if I run this code, yeah, it cannot infer the type for this. Give it like a explicit type where the type is specified. The problem is I don't know what, I don't want to give it that type. I want to build like have world take in any number of types. You're doing good. Awesome. How am I doing? I'm doing good. I'm happy to be back in streaming again. Back in like continuing my Rust journey, which and game dev, I guess, a little bit too. All right, so we have world new. I don't want to like have to give, oh, it's world that needs it. So it would have to be something like this. I could say something like, oh, you're at F32, and that's fine, but that's clearly a problem. I don't think I can do like something like, oh, static. I don't think I can do like here, entity. It's entity, but now that needs its own type. Because now entity needs a type on top of that too. So that's an issue. You've been learning Python programming recently. Awesome. How are you enjoying Python? So another problem that we have like with generics here is like at some point in time I have to specify what the type is going to be, and I don't think I can say you're an any type, because that would be I think I have to give it like a specific type and not a trait. So like if I do core any, like this shouldn't work. This should yell at me saying, hey, what the heck are you doing? Yeah, trait objects without explicit dyn are deprecated. And so at that point, we're getting to dynamic dispatch, and that's a different problem altogether. So you want to create a world instance that will create any type, as in entities can be different types at the same time. Yeah, that's kind of like the idea. And I think this is like where generics aren't going to help me. Python is a fine programming language. Yeah, it is. It allows you to do so many cool things. So I think this is telling me that I can't, I'm not going to be able to, because like the problem is I want to be able to store a hash map that stores like these entities here. And this is where it gets into trouble. So if I want to do components where I don't know what the component is, problem. And if I like create a component trait, so let's say up here I do hub trait component. Let's say I just do even this. Like I just have like a marker component trait. And we have an entity. So instead of like a struct entity, I then want to say, okay, you're actually going to be this component. Is coming in as T. Add in T here. So you're upset. Trait component is not implemented for T. Then I need to like say what that is. We're running into a little bit of trouble with this. So I think that's enough for me to say, you know what? Generics, I don't think you're going to work out for me. So let's look into dynamic dispatch. I think this is going to be the one that works the best for us. So let's say we have, let's not worry about component. necessarily. Let's create an entity. We're gonna have our data, and our data is gonna be a box, and its type is gonna be core any. I recently learned about core any. This trait is basically, it's gonna be dime. This trait is basically used on any of the basic ones. If you want to have a world that accepts different kinds of entities, you can create an entity trait that is then implemented by different structs. I thought, let's see. Yeah, that's what I was trying to do with like that other one, but maybe I did it incorrect. Maybe I was doing it incorrectly. Like instead of a struct entity, I guess we could do trait entity. Or it would be trait. The entity is like the full thing across all of them. So it's actually not entity, it's actually component. So here, let me go backwards a little bit. If we do hub trait component, I don't necessarily know what to throw in here, so we're just gonna have that. Then we say, okay, pub struct world is T component, where we have the hash map of the name of the component and then where this, then a vector of this component. So, well, that's explicit dyn. So then we're back to dynamic dispatch then. Unless I do something like it has T component like that. I don't think I can do that. Yeah, type arguments aren't allowed for that. Where T is that, are you happy? T is never used. Oh, vec of T. Dota 2 attitude, hello. Yes, I'm a little bit rusty with Rust. It's been like a month since I've used it, so definitely a little bit. And you know what? I keep on using Rust. I probably won't ever stop getting rusty. It's just there to stay. Consider removing T referring to in a field. So it doesn't want me to do that at all. This new Rust project? Yes. Okay, so you're happy here, sort of. Oh wait, no, you're not. What happened? Where are you upset? T is component. There we go. Now you're happy. Okay, so impl T, world T, the treat bound T component is not satisfied. Oh, I need to component. That's a test with logic in it. I'm mostly using this to like actually test the thing out. It's not going to be a real test. Wrong number of type arguments. Expected 1, found 0. For the component or the T? Wrong number of type arguments. Do I need, do we need a where here also? Like where T is component. Yeah, okay, that's it. So now, if we do this, world new. Now, here's the problem is we still have the same problem here. Type annotations needed for T. And I don't think I can do like a component here because that's a trait, not a type. Terribly disbound in world. And then I don't think I can do a dyn in here. It cannot be known. Yeah. So problems abound with this. So I think we can get close, but my knowledge of generics isn't high enough to be able to like implement this myself. I would need to like study a lot more with this. Flint, Rusty, hello. So I'm thinking dynamic dispatch is the way for me to go with this, which is going to be very, very, very similar to this, but instead of like a vec of T, so instead of using generics like this, we'll say that I want components. So the component is going to be a vec, and then I'm going to store a box, and then inside of here will be a dyn component. So it'll be like this trait component in here. We don't need you. We don't need this where. Okay, so we now can create, we don't need this type. We create a new world. We register a component named location. So that comes in like this. Why are you claiming that you're not? Oh, it wants me to implement a default implementation that's exactly the same as this. I mean, that's fine. Oh, and you have some code for me. Let's take a look. Public trait component, public struct test entity, implement component for test entity. Oh, right. I keep on forgetting you have to implement it for that to work with there. Well, right. Once I get into this, yeah. Okay. So dynamic dispatch. Yeah, we're getting to that one now, I think. Where we now have this box dyn component that's added in here for like a trait. And it's like the user will provide different structs to like sort of go in and we'll figure that out. And so it'll be like a vector of like whatever we feel like. But the thing is that I might be able to get away with not even using a trait component if I just do very basic things, like tuples of like F32s. I might be able to get away with saying that you are going to be a core any. So then in here we have this location. Okay, so we have our location, and now we registered a component, and now we want to create a bird that has this in there. So if I create an entity, how would that work? So we're going to do something like world dot create entity, and then I need to pass in all the things that I care about, really. So it'll be something like world create entity, maybe dot like with, and then the name. So it would be location, and then like pass in the location here. So if I do something like that, okay, so you don't have a create entity. So we create an entity. I don't necessarily care about this at all right now, and we're going to return a mutable reference to self. Okay. So then what I want to do is I want to go through all the components and insert, like add a new empty something to the end of the vector. So that way we know what to like throw in there. The problem is that means there probably need to be options inside of here, doesn't it? So it's really going to be like an option around this box. So if I do that, you don't know how to learn types faster, but you want to. It's a major slowdown for you productivity wise. That's sort of like what I'm like doing here, is just practicing with it, building fun little projects that that require more advanced type usage. So I guess like that would be my suggestion, is like build something that requires like that's just outside of your skill zone. Not too much, just a little bit. Okay, so we can return self at the end. That'll make that happy temporarily. Now inside of here, we want to, I mean, fine, I'll it's because I turned on all of Clippy stuff. That's fun. All right, let's see. Oh, you have no time for extra projects at the moment. You're doing coding 50 hours a week. Oh, wow. Okay, yeah, that is a lot. Hopefully you can reduce that down a little bit, and then you'll have time. I try to give the people on my team like 40 hours maximum, really, so that they have the time to like self learn and not burn out. Okay, so if I'm creating an entity, like the big thing here that we're doing. So when creating a new entity, we will want to add a new element to the component vectors in preparation for that entity. I can actually even put this like that. It's just Markdown for this documentation, so I could just do the single line and it's still actually part of the previous line. Okay, so the first thing we want to do then is go through, loop through all of our components and insert, just like push in a none for everything. So let's mutably loop through everything here. And I think if I do that as, you try not to go over 10 hours per day as you're just useless after 10. I mean, that's still a lot. There's some evidence that after like 6 hours, there's not really like, it's really hard to concentrate and get like high quality work for really any type of work. So I don't know, like I've worked really hard with my company and like we've now defined a day as 6 hours. Now like people are there for 8 hours, but those like 6 hours of like actually working, then 2 hours of basically just being there, doing like administrative tasks, checking email, chatting with each other. It's basically like things that you just are gonna do at work. And then 6 hours is like, some people will get less, some people will get more. It's an average, really. Okay, so let's loop through. So I think what I can do is self.components. I think I could do a iter mute. And then we can map. No, I don't want to map. I think it's just going to be a for each. Okay, so then we'll get this function, and inside the function, we're going to get the component. And we see here that now we have this tuple that has the title of the component and there. So I wonder if I can actually extract this out. We're going to have the name and the actual component. Components, because it's actually a vector of these options. Then inside of here, I want to add to this component. So we're going to do components dot push a none inside. And we don't really care about the name here. So create entity will initialize by like adding a none to every single one. Okay, that's fine. I want to look at a DDD overview. What's DDD? Like what does that mean? I probably know what it means, but I just forget like the acronym. Okay, so we have this self. Oh, domain-driven design. I have heard of that. Yeah. I haven't looked any books with it. So yeah, if you have any good ones, send it on over. I can't promise that I'll have time to like actually read it. Let's take a look at that. That's at GitHub. Yeah, I've definitely talked with this with the architect and some other people at my work. So I wouldn't mind learning a little bit more about this. I'll add it to my list. Do the domain before the database. That sounds like something I would like to do. Okay, so public function with, gonna take mutable self. Now notice that we're taking in a name here. So a name, which is a stir. And then we're also taking like the actual data. So this is, I guess it's like the component or maybe like the data. And you're a little bit more interesting. So I'm gonna want this to be matching what this dyn is essentially. Like we want it to be anything that sort of like matches inside of here. So you're probably gonna have to be a box, a box with a dyn for any. And we're going to return a mutable reference to self. So we'll just return self right away. And then when here, we'll have to get the component out. So let's say this is gonna be our component. We know you have to be immutable. Equals self dot let's see, self dot components dot get mute. We pass in the key, which is really just a reference to the key. So that's the name. That gives us an option. So now we have this option here. So if let sum, this will be now the component again. So really I can just do the if let right here. So if let sum component is equal to this. We don't want you anymore. Okay, so if let sum equals that, it's a mutable reference to this. Is okay. So now it's our components. Now we have this. It's our vector. We know it's the last one that comes in because the width should always be. Let's see. Width is always called after create entity, so we can be sure that the last element of the vector is what we are updating. Okay, so we want to take the last one of these and change it from a none to a sum and then pass it in that data. You do that a fair bit, make methods that are dependent on each other, or am I wrong? This is more of like a builder type pattern. So like you create entity and then I'm able to like do then dot width. I could do it like without that, and then that changes who cares about it quite a bit. But this allows me to chain them. So like it goes back and forth a bit on like how I feel about it. In this case, yeah. Why are they dependent? It's like it's a soft dependency. It's not a hard dependency. Like I can call without create entity. It's just that in this case, the width is assuming that we've already added another one in here. Like we've added a none to the end of all the components. So we want to take the last component and then add in a sum data. So this is going to be components of position components dot length -1, and I want to set that equals to be a sum data. Cannot borrow components is immutable because it's also borrowed as mutable. Ooh, okay, so I can't actually like figure out what this is. Now I could like have a length of how long like stored separately, which kind of sucks because that's, you know, it's already stored inside of here. We should know like what our length is by like grabbing that. You know what? I can get this out here. Let length is equal to components length +1. So actually I want you to be index. So you should be happy there, and then you are the index. So if I understand Rust right, the language makes it difficult to mutate. Let's see, would that be correctly? Which means you're more likely to get a thing, create a new thing, return a new thing. Basically, it's the protections in Rust are to make sure that you can't mutate at the wrong times. Or get something that no longer exists. or mutate the wrong thing. So then you have to work around that a little bit. So you can see like here, I can't like actually do the get inside of here. I have to do them one at a time. And what's interesting is like, yeah, you're saying that it's like a functional language. Rust isn't a functional language, but it makes it really easy to do functional. Like it sort of like steers you in that direction a little bit. That being said, I haven't used any purely functional languages before. I've been like talking to some people who know Rust and have used functional languages, that they were telling me that that's sort of like the direction that it is, and I believe it. Okay, so then this now will set, like I get that component and I set it in here. And so now you're saying that I need to box this up. So like a box new, and you need to have the location inside. So no errors, just a warning that it should have a default implementation. We can let's do that to get that warning out of the way. So I'm gonna impl default. Actually, you know what? I might be able to. This might work for me. So in here, we're gonna do derive. Oh, come on. Derive defaults. All right, that works. Let's see. From Wikipedia, paradigms, multi-paradigm, concurrent, functional, generic, imperative, structured. Yeah, it's multi-paradigm would probably be the closest to explain like Rust. Oh yeah, you didn't realize there's no garbage collection. Yeah, so garbage collection is not a thing in Rust. It's actually like, that's one of the features and that's one of the reasons why, but they have like these structures to force garbage collection to happen at certain times, so you know when it's happening. So as soon as something goes out of scope, it's garbage collected right then. Like it's just removed from memory. I don't have to manually do it with a drop. I could do it with a drop, but that's rare that I have to do that. Okay, so I've created this entity with a location. So you have that first vector with locations. So let's do the next one with what would it be? It would be, I need to do, what is it called? Velocities now. So world dot register component velocity. Okay, so we're gonna have a velocity. So I don't have to do, like I can do this both here. So like I name location, box new, a location is gonna be 0.0, 0.0. So get rid of you. Velocity is the derivative of a position. Or in this case, it's like direction and speed. I guess that's probably the same, right? Well, I'm using it here as like direction and speed. Okay, so then I want to then say dot width. This has a velocity of okay, so box new, it's direction and speed. So I'm going to do the same thing of the tuple for the x and the y. So let's say like this is 15.0, 15.0. And there we go. So I'm now going to add in velocity. I don't think I have to change anything up here. It's all just going to work. Now we have a location and a velocity. So we have a bird that is both of these. Okay, so if I wanted to update this and run this, and then update the location with the velocity, so maybe some like update loop that we do that with, what would that end up looking like? I would need to loop through, so I need to get all of the locations and I need to get all the velocities. I know that they're all the same length because I'm forcing that. That's also like the negative is we have options for that instead of just like the values inside. Not the best. First location, last location. How do you get the time? Then you get average velocity. Oh, well, like right now, I don't really care about the average velocity. Right now, I'll probably eventually care about that. But I could like get the average velocity by just looping through all the velocities and averaging them together. But I probably have to also do some like a grid or something to determine where things are within, like to query, hey, give me all the velocities within this location. So that's going to be interesting too. But right now we're worried about like the ECS part itself. So, okay, so we have this world, we have this create entity. What do I need to do with it? I need to test updating the locations. So that's going to be like a system. I need some kind of like system that's going to, and that's the S in like ECS. That's going to update. So what would that look like? If I have a function, let's do like update locations. We'll just call this like a system. Now inside of here, I could pass the world in. So we're going to take in the world, which is going to be a type world. And it's going to mutate here. After we do the mutators, we probably want to then get all the locations, which is just going to be one set of them, and test to make sure that it's the correct velocity. Okay. So what would that look like? We would say, let locations equals world dot get, oh, and then pass in location. Like I want to get all the locations here. This doesn't exist yet, so it's going to error out. Then I want to, we could do our assert equal that locations of position 0. You should actually be a tuple of 15.0 F32 15.0 F32. All right. Now a get here, that doesn't exist yet, so let's actually add that in. So pub function get. Get, we don't need to be mutable. We probably want to create like another one for get mute, which is going to happen inside of here. So we want just a reference to self and then the name, which is going to be a stir. And we're going to return, what are we going to return? We don't know what we're returning. So it's probably going to be this vector up here. That's what we're returning. So if I copy you, throw you in there. You seem to be happy enough with this. So let's get this out. This should be relatively simple. We can just do a self.world self.components.get, then we pass it in the name. Now that returns an option of these. That's probably for the best. Because that way, if it doesn't exist in here, that's what we're getting. Mismatch types, expected, enum, standard option, all of these. Okay, so hold on. What? Let's say I return you. You're gonna yell at me. Okay. Found an enum, standard option with a reference to a vector that inside of it had an option that inside of that had a box dyn standard any. So if you did on the object is location and the time relative to something, probably the creation of the world or the object, you can calc velocity from that 2 positions 2 times. I kind of get what you're thinking of. If you enter velocity into a given position, you should end up at that position in a given time. Yeah, there's several different ways that I can do that. I think I'm going to do this like tick based. So every tick, I update the location with whatever the velocity is. As opposed to I have to like calculate, okay, how much time, the delta time, calculate the velocity by the time. I think I'm going to do like a much simpler version, which is every tick, the velocity gets updated, and I can basically limit myself to X number of ticks per second. So I can do 60 ticks per second or 30 ticks per second, depending upon what our FPS is going to be. Okay, so you're unhappy there. So what are you? Yeah, tick should be frame. I've heard it actually like references either in game dev. But yeah, like frame is also right. So we're going to return an option. Inside of the option, it's going to be a vector. Inside of the vector is going to be an option. Inside of the option is going to be a box. Inside of the box is going to be a dyn for any. But it's not, because you are a reference inside of here. So we're not giving the actual vector, we're giving a reference to the vector. There we go. Okay, so that's what we wanted to get. So then we get this. Okay, so location set 0 cannot index into a value, right? Because this is an option now. So I want to actually just unwrap this. Because we're in this test, we know that it should be getting out, so we should be fine with that. And then locations is now this vector. So I want to then unwrap you. Right, now we don't know what you are. And that's a problem. It's like, it's gonna be hard for us to test this. Because saying like, hey, you have this box of any, but you also have this thing. How do we know what you are? So that's gonna be interesting. To like do proper testing for this. I would assume in the game they made 1 frame equals 300 to 400 milliseconds as a typical reaction time. No, it's actually much smaller. So 60 frames per second is like the minimum these days that you're targeting as a game dev. At least for like modern games, like oftentimes it's like much faster, like 90 frames per second. Although update frames is like update frames and video frames are different. Like they don't have to be the same. So I would say it might be something like 50, 25, 30 frames per second for updates. But I've still heard like 60 frames per second for some systems are still good to like target for updates. That's 16.3 six repeating milliseconds per frame. If I double that to like 30, like that's like, you know what, 30, 32, 33. So it's less than 100 milliseconds per update loop. That's still pretty fast. You might be surprised how fast these run. Like these update loops can run really fast. A run frame length means you hit one button and the next button in exactly the... Oh, okay, sorry. I was thinking like, okay, in that case, what you're probably doing is you're probably creating some kind of state management system, like a finite state machine, and determining, okay, like when you press the button, it switches the state to like button pressed. And then you're just waiting for the state to be a button unpressed, and it's updating very often, but it's only checking, like trying to figure out what the next state is going to be and listening for that. It's probably a finite state machine in those cases, which like in Rust would be like an enum. I'm pretty sure SF4 runs at 30 frames per second, but they refer to frames as something entirely different likely. Yeah, that's it. So in my mind, it actually helps me. I think of them as two different things, as ticks and frames. The ticks I think of as the updates, and the frames I think of as like the graphical loops, which I know they both are interchangeable, but I think like in my mind, it just makes a little bit more sense. So the problem here that I'm running into is like, it's really hard to now, I don't know how I can like do this properly to figure out what you are, except, you know, I wonder if I can like tell it what it's going to be. Like, can I just say like, let location is equal to, let's go like locations of position 0 and unwrap this. Is this box dine any? Can I tell you what you are? Can I say that you're going to be a box with a specific thing? It's like a tuple of F32, F32. No, because it doesn't know how to do that with like the dine center any, like that's fine, except when I try to test it. That's going to be a little bit more interesting. What else can I do here? So I have a box. If I do dot, it performs a conversion. We can downcast. So downcast the box to a concrete type. So we could try doing that here. So just downcast it. So in this case, it's no longer a box. It's now going to be that. Expected tuple, F32. Oh, I may not be able to explicitly tell it what it is. Yeah, defining tick first frames meaning seems important. It helps my brain. Okay, so if I do that, oh, it's a result. It's a result. So now if I unwrap this, it's a box unknown. So now let's just do this location. I want to check to see if you're that. Expected struct. Box, found tuple. Oh, can I say that what you're going to be, which is a box, F32, F32. No, so I can't expect that they're exactly the same, but can I just do this? Box, new. I don't think I can compare them together like that. Can I? Okay. So maybe. So you input a position and velocity, increment the tick, and it gives you back a position. But the position's been incremented now. That's the idea. Okay, so if I do that, cannot move out of this. I don't want to, because, okay, so borrowing. So maybe I can borrow here. Mismatch types, expected struct, box this, found reference. Okay, so what if I don't tell you what you are? Now you can't compare box of unknown thing with box of that. Partial equal is not implemented for, oh, reference. Okay, so then a reference there. Cannot move out of index vector. Okay, so it's actually one of these other ones. So like this gives us this, so we have the vector of options. Then we get out of here, we get this option. And then downcast, this might be, probably use the getter on position for X and Y and compare them directly rather than a whole object. Yeah, it'd be nice. And I could like store maybe, like we could, instead of like this any, we could create like a component trait that would allow us to have like a getter. That could be nice. And then just force everything to have like a get on it. Cause like we're running into this, which is like a little bit nasty. It's like if we unwrap to here, we have this box dyne any. And yeah, because like any so this and any can't be compared against. That's our problem now, because like the downcast. Now I wonder if like I try to downcast here. Oh, then unwrap. Now, can I tell you what type you are? So used to compare object A to some unknown object A rather than A.x compared to int. Yeah, I probably should do that. Maybe a type check on A also makes sense, as that will tell us it is an object A and has the same properties. So the problem with any that I'm running into here is that I can't like tell it what's in the object. It doesn't assume that. So maybe what I need to do is have a trait. So like public trait component. And then we'll have like a get. So a function get on here that takes in a self and returns something. Well, there's a problem altogether. What are you returning? Like, we don't know because we're storing anything, like just something in here. So in that case, does this need to be like a generic? Or is it really like we're returning a box? Well, that's the same problem we're running into again. So if I return, like, do I want like ints? Oh, like primitive types, like int strings arrays or like F32s or whatever. Yeah. So how do I tell it that it's a primitive type? If we go, let's go take a look at the, let's see. Actually, I think I have somewhere the documentation open to, where's the full, they sometimes have links to documentation. I don't see it here though. Oh, that's too bad. Oh, standard rest. Here we go. So if I look for like F32, here's standard F32. Implementations. So implement F32. So it has all these things on it. Trait implementations, so add, clone, copy, debug, default. Okay, there's auto trait implementations. So like the blanket implementations, any, borrow, and that's it for that type. So that's a problem. There is nothing to like say, hey, all numbers, like all primitive types have this. Like there is any, which I'm using right now. And maybe that works. Like maybe I could say, you're gonna return a dine for any. You don't seem to be, well, okay, you're still upset from down here. Let's get rid of you. Okay, so you're not too terribly upset with this. So if I do this though, now we're gonna need to create, okay, so we have our world, we implement the world, but now we're gonna have to create a component. So I'm gonna do this inside of tests because this is outside of like normal space in this library. So I would want to do something like struct like location that'd have like an X of F32, a Y of F32, then impl component for location. Sometimes a class has properties that are other classes. Yes, but there's no classes in Rust. So then get, we're doing dine standard any. So if I want to return the location, I guess in this case, let's actually make this a tuple for like F32. Then I want to return self.0 self.1. Like struct is the closest that you can come to like a comparison of like a class and Rust. Okay, so then you're gonna yell at me. So the size cannot be known at compilation time. So perhaps this needs to be a box. So In that case, we need to update you. So you're like a box. Dyn core any. So you're a box. Dyn core any. And then you are a box new. And that's what we return. So that's happy there. Now we have this component in here, so we're going to update this. A vector of option boxdyn component. So it now has to be components that are like wrapped, essentially. So with some, okay, so data now has to be boxdyn component here. So you're happy there. Okay, so get off of here is going to return an option vec dyn component here. All right. Then down here, okay, when we create a new box, you need to take in a component. So it can't just be this anymore. It's going to have to be something like we have this location that we're testing. So it'll be location with like 0.0, 0.0. We might have to do this the same thing here. So struct a velocity component, which is an F32. Now, ironically, this is like exactly the same. So what if instead of calling this, I can't call it like a vector. That's not the best idea. I can call it like a point. Call this like a point. That might be better. So then you are a point. Okay. Now you are also a point. Okay, so that makes you happy. So we're gonna get the location. So now we have this like vector option boxdyn component. Okay, so let's get the first thing here. So to unwrap, I want now position 0. That gets this box. Let's unwrap you again. That gets this box. And then if I .get boxdyn any. So that gets us to here. Cannot move out of here. Let's see. That's not going to be helpful. I don't think I want to do these all together. Line set. Oh, I need to turn on the line thing. Hold on. Let me do that. Where's my line? There. What? Oh, I have to reset my key. Probably it probably expired or something. It's been like forever since I've used it, so I know. Okay, line 71. What was that? Does that do? What do you think it does? Those chain methods. Yeah, I know. It's pretty nasty. Okay, so right now we see that if I just do this, yeah, let's just go back to this beginning. If I do a world.get location, we now have an option that then holds a reference to vectors. So if I unwrap this, now here's the vector. So we get our vector of this. Mr. Halsey, hello. What? Wait. Auto mode. Allow. Mr. Halsey, hello with the with all of the emotes that apparently my Autobot didn't like. Also, hello everyone with the that came in with the raid from Mr. Halsey. Welcome, 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 Mr. Halsey. How is working with it was Godot with using text and having it wrap around, right? How is that working? And since we got rated, let's go ahead and set ourselves up the drop game. Oh, you hit a wall. Yeah, that happens. All right, documents. Oh, come on. Code. Okay, Brooks builds the. Come on, where is it? Like how every code session of yours ends. That happens. That happens to me so much of the time too. Right, we're going to the Rust workspace. The Rust workspace, and then inside of here, we're going into the get the streamer game spelled correctly, and now I can do a cargo run. What was it? It's cargo run. The compiled. How'd coding go? You solve some stuff, ultimately hit something, couldn't figure out, and gave up. Cargo burr. I know. It's been release mode. That's what it is. It's been a while since I've done. It's been a month. I've like forgotten everything about what I'm supposed to be doing. Let's see if this still works, or if I need to like update it. No, it still works. All right, so this is the game we play whenever we get rated. So I'm gonna be running around on the bottom and trying to avoid all of you who are going to be attacking me through chat. You can do all these things on the right to get at me. So I have 2 minutes to try to avoid everything. We played this one game one time after getting like rated by like 60 people, and it got really crazy really fast. It'll also be interesting. I've been playing a lot of Hollow Knight recently, so we'll see whether or not I've been getting better with these type of games where I'm like avoiding being hit too much. I have to remember what my hit box looks like. Enough to be hit by that. Let's get on to the center. Yeah, let's see. I kind of like to be in a center where I can like go left and right to avoid things. I had to take a hit there. It's those snakes, really. Like they change everything. I'm almost gonna win. Yes! I am just too good with this. But, oh, Chantilly Cake with the 48 points this time. Awesome. So thank you again, Mr. Halsey, for doing that, coming in with the raid. Let's, all right. Switch back to our code. Let's figure out what we're trying to do. So what I'm experimenting with is creating our own ECS system that I can use in games or simulations. And I'm hoping to be able to like learn enough about ECS to build this myself. And it's really interesting where I'm trying to say, okay, I want to like get, but I don't know what I'm returning. Now I could say things like, if it's a number, what is something that like all numbers have? Like all numbers have add. So, and then I can like add to this as I like add new things. So what would that be? I want to add a Boxstein core. Well, so instead of like core any, maybe it's like add. The type parameter RHS must be explicitly, oh, right-hand side must be specified. Oh, I just want you like that you have the trait add. I don't want to like actually implement add. That's probably not right. Oh, there's two adds. Interesting. Yeah, okay, so this is a public trait add. Oh, set the type parameter to the desired type. Well, that's kind of like not what I wanted. I suppose that I could do generics here. It's like a box T. And then I would need to come in here and say like T. And then you're happy, but then I need to go like where T is maybe add. If I do that, then component wrong number of type and the type argument. So then that's the next problem is I can't do the type arguments. I'd like need to continue to do that, which is not helpful in here. Unless it's like type T and then I like have a T here. Okay, so that's actually happy all the way down to here, where we say, okay, with function with, right, so we're taking this component with type T. Okay, you're happy here. Okay. Very complex type use. Consider factoring parts into a type definition. Okay, so that's not terrible. Now implement a component. I need to give it the type, right? Right. Okay, so struct point, implement component for point. Silent Z, hello. Have you seen HashMap with type ID as keys? No, I haven't. Well, okay. I've seen it, but I haven't looked into like what that really means. Would that make it easier for what I'm trying to do? Because I saw that Hex was doing something with type ID. I didn't like look too deeply into it. Okay, so if I say like component here is actually this like F32. So it's like a specific type like this. I wonder if that's going to make it easier. So then down here, yeah, here we go. We have you like that. So now we have locations coming out. Now I'm wondering if do I need this to be dynamic dispatch anymore? Or can I just do this as generics? And like this would be back to the generics option again, but now like actually working the way I want it to. Where I have this trait component like that. Components, HashMo string, affection option. What if I don't do a box? What if I just use this as an option component T? So I'm getting one of the opens. Like that. No, okay, so it still needs to be boxed up. Can I get rid of the dyn? Which is component T? No, trait objects without explicit dyn. What if I give you a T? Okay, what if we have 2 opens, 3 opens, 1, 2, 3. What if I give you like an option T here, but then I say where T implements component. Wrong number of type arguments, so I don't know where like I then need to say like component is like T and then backward, like we have a recursive typing. That's not going to be helpful. Cannot add T to T, exactly. I guess I could do things like where T is add here. If I do that, do I not have it here? It's like where add, for example. That's not helpful. So I think I still need the dynamic dispatch for this here. Very complex type here. Okay, so we can actually do pub type. What is this going to be? This is going to be like the data. So it's like data. It's really like component data. Is it equals? I don't remember how it works. And you are going to be a component data is a vec with an option, a box, the dyn component. T. And then I need you to be, is it here? And then you become this. So a component data. T. All right, so that makes it a little bit easier. IBN Bala, hello. I'm doing good. How are you? All right, so we have that. Now back down to you. Where's our error? Okay, so world is coming. Let's actually not worry about this for a second. All right, so impl component. Okay, so we're creating a component that has this tuple of F32, F32, which is basically what this point is going to be. So 4 point, right, because like tuples can't add these together. So we have to figure out like, what are tuples? What do tuples have? Because because that's a problem that we're running into. So tuple primitive type does have equal. I don't see much else that it has. And nothing else. Okay, those are just other things. So I don't think this is as easy. Unless I can do something like plus, like somehow like a tuple that has like add, but I don't think it did. Wait, it didn't hate that? I did not hate that. If I just do like an F32, that's going to be happy. Oh, the type and trait. What are you up here? Right, because now you return just like a box T. So you return this box T. Can I actually say what you return? Like an F32? So this could be like self. 0. All right, so that works. Now the problem obviously being that I want this to be a tuple for the X and the Y positions. Now I could have like just X and Y like separately, but that like most of us think of like points as, you know, actual X and Y, like this tuple here. So I really need this to figure out how this really is going to be an F32, F32. We need to figure that out. But this isn't helping out here. Now, I could have trait components where T is, oh, like plus. Oh, okay. So where T is add, is the common or? T is it possible to have ors in this, or is it not? I don't think so. I think it is like them together. So if I do something like tuple of add, I don't know if that works. I think I would need to say add, right? Expected right paren. I think I can do, let's see. Yeah, I don't know how to do like them together. To say that this is it's like add is not implemented for this tuple. Okay, so add is probably the wrong thing. Now I could go back and do like, hey, it's the core any any, which is what I saw that like Hex was using. It was like core any. The problem here, so if I do 32 F32, okay, box new, self.0, self.1. Okay, ooh, no errors, just warnings. Oh, and so this gives me that there. Okay, so then I think we're fine again. So here we get our locations, which is now a reference to our vector of options. If we grab the first one here, our location is this location's of 0 unwrap. We now get a reference to the box. If we do that, we get the box. I really don't want to like take ownership of it. So it's reference the box, define component. So then I want to get that. What's the difference? Oh, box define components. Okay, so now I don't know if I need to downcast this anymore. Can I just location? Okay, so this box sign component, which has that. I need to get it in order to not be a component anymore, but rather to be the thing. So in this case, we get this and it just becomes this tuple. So we do location.get. And okay, now I want you, can I get away with this just being like a tuple of 0.0, 0.0? No. Okay, expected structure, a box of that, found a tuple, float. That's fine. So let's box new this. Okay, no error down here. Cannot move out of here, so I don't want to. Okay, so locations, let's do this one at a time. Locations.0, so that gives me this option. Now we could just do an if let here instead of like the unwrap, because I don't want to like actually take ownership of it. But let's try that. So if I do like an if let, some location equals this. Now I have location is, okay, this box. Now going to assert equal, no errors. Okay, so we have no errors. So we want to assert equal, the location I get is box is new. I actually want this to be equal to like the velocity here. So we're gonna say 15.0, 15.0. All right. So if I run this, it would be cargo test. It ran, it compiled and it ran. The problem is that it's not 15. It didn't do the thing. Well, it didn't do the thing because we didn't program for that. But we're moving forward here. We're getting forward momentum. So let's actually create our system for this that we're going to use. So let's actually do that up here. We're going to have a function. What is this called? So I want to update the locations. So update locations system. Let's say that we take in a world, which is going to be a mutable reference to the world. I'm not going to return anything. So the first thing I want to do as the world here is I want to get the locations and I want to get the velocities. So let mute locations is equal to world.get, and this is going to be location. So if I do that, okay, so that gives us an option here. Now, I don't know if I want to like unwrap this or like convert it to an error or something like that. Book club time. Good luck. Oh, you meant bang. All right, now to book club. Well, have fun with your book. What are you reading? Or if you have time. If you don't, then have a great book club meeting. Okay, so with these locations, let's also let mute velocities. Blue Book of Domain-Driven Divine. Oh, is it that book that? Is it this book? Or is it a different book? Sounds like it might be a slightly different book, but Domain-Driven Design is always fun. By Eric Evans. Ooh, another one to look into. Cool. Called Domain-Driven Design. That kind of makes sense. Well, have a lot of fun with the book club. Okay, so we're gonna do a world.get. So we're also gonna get the velocities. So get the velocity. Now we have two options here, which is not the best. And the only reason so options are coming because out of world that we're getting. So we can do unwrapped. We can do like an unwrapped, or I guess like for right now, we'll just do an unwrapped. We'll have to figure out what our error is going to be. We probably want to do an error on the world itself and have it return an error. Okay, so wrong number. Oh, we need a type argument for this. Oh, okay. So then you need to be like a type T. Like that. Okay, so we have our locations and our velocities. They're just pure vectors. So we need to get the length of these, which we have like by one of the vectors, and we know like the length is the same across all of them. So that's probably a good thing to have inside the world. So I have something like pub function get component length, and we're going to return back a USize. So we're just going to return self.components. Well, it can't just be components, right? It has to be like, we have to get one of the elements inside of the component. So we don't necessarily know which one, do we? That's interesting. So you have to get the first one out. We don't know what that one is. I can get like an iterator to get the first. Might not be the best way. Let's just like keep this in here for right now. So we're gonna say let index, no, but let length is equal to, okay, let's just do locations. dot length. Okay, that's fine. Then we want to for index in 0 dot dot length. Now we can get like the current location. So let like a location is equal to locations a position index. So it gives us this option here that velocities index. Now I want to loop through. I actually want to loop through all of the locations and mutate them in place. So what's the best way to do that? Probably like a for each. I don't want to like reassign, so I don't want to like do a map. So maybe the best way to do this would be, oh, and I need the index. So actually, I don't think I need to do this. What we can do is we can say locations dot, let's turn this into an iter_mute. And then we're going to for each. We're going to have a location. So it's going to be this option box. Okay, so we have this location. Okay, so I need to get out of this like option. So if let sum location is equal to location. Okay, so now I have this mutable box dyn components t. Okay, so that's good. But I need to iter_mute. I can't remember if it's before or after. It's after probably. So iter_mute and then dot enumerate. Which will give me the U size. So I need to parentheses. This can be the index and the location here. Okay. Now, if let's okay, so now I have the location extracted out. I want to mute the location. I don't know if I have to tell like it's a mute here. It's like a mutable reference to T. I guess can't really do that. I can do that though. I don't know if that works. Send in here. Okay. It's a function. Get mute. So can I do a box new, but inside of here, we're gonna have a tuple with a mutable reference to self.0 and a mutable reference to self.1. Will that work out? No. Okay, what do you need to be? Can I find T in this scope? Oh, right, because I tell you what you are. That's the thing. You're a mutable reference to an F32. Mutable reference to an F32. Mute is an incompatible type for trait. Ah, okay. So I wonder if I need like a set. Like a set for this. To change it. In which case I get it first. And then I set it. It's not the best way to deal with it. Because like down here, we're gonna say, okay, update locations. So we have our locations. We have our velocities. We have our length. We have our, okay, so we iter mute. We enumerate. Okay, so we have all that stuff. We have the location. We need to get the current location. So that gives me a box T. Wonderful. But that should be essentially a tuple of F32, F32. And I wonder if here, oh, I can do that. Usage of box T. Try. Oh, okay. Redundant allocation. Are you happier? Oh, because I think it's here. That's what it is. Okay. So then in here, your immutable reference to a tuple with self.0 and self.1. Okay, so then if we have a location, can I do a get mute? So I wonder if like I can now set this. So can I wonder if I need to set you as mute. And can I now say like location dot 0 is equal to like, I don't know, 300.0. If I just do that, okay, so you're not happy. Mismatch types. Okay, so they're private. So we have to come up here. How do I tell you that you're public? Because like location 0 coming out of here. So if we do a get mute, wait, where is that? Get mute. So we get this. Self.0, self.1. Do I have to like dereference? No, I think I can dereference or something like that. Can I like debug? See what I've actually got? No, because you don't know. Oh, T doesn't implement debug. Where T is core any. Can I also do that? Or is it plus debug? Oh wait, what's the trait? It's like standard. Standard D. Oh, where's the trait debug? standard format debug. That's what it is. So standard format debug. Okay, so get mute. Okay, T doesn't implement standard format debug. I wonder why it's yelling down here for that. And this is because get mute is like saying, hey, I'm returning this thing. This is like what I'm returning. So we run get mute. I guess I am trying to restrict it. Why are you yelling at me down here? Up here. Oh, impl also has to require standard format debug. Okay. Wait, where is that? The component has this trait. Impl also has to require that. Where is that then? That would be the impl for world? No, for this component, for this point. So impl. Oh, okay, hold on. Can I derive debug? Yeah, there we go. Okay, thank you, Nathaniel Bumpo. Oh, wait, no. That didn't work. I thought it worked. I wasn't zoomed down enough. T doesn't implement standard format debug. Okay, so I thought maybe telling like the point that it was debug would work. The impl, do I have to like manually implement it? Do I have to use generics here? T standard format debug in your constraints. I guess like where's my constraints? Because I thought I was doing that up here. Saying like, hey, standard format debug with this. But oh wait. Maybe I did it wrong. Maybe it's here. Maybe I put that in the wrong place. Oh, it definitely doesn't like that. I'm getting the error down here on my get mute. So here's my get mute function on impl component. T doesn't implement standard format debug. Line 71 constraint. Oh, I have to put it here. No, stop that. Standard format. No, stop that. Debug. Did I just like... No, I didn't use like another use statement. That's weird. The function update location system has a T. Yeah, I completely forgot that I had that in there. Okay, so T standard debug. Okay, so now what? The parameter type T may not live long enough so that the type T will meet its required lifetime bounds. Okay, so I've noticed like specs requires lifetime arguments in there. So this is like Okay, this is following along with like what SPECS requires. So if I were to, I know, lifetimes. Oh, okay. So if I do, lifetimes come first. So if I do something like A, and what are you? So T, okay, so this. Where do I use it? Is it here? Or is it here? It's not there. So I have a lifetime now, and I set the lifetime. I wonder, might be able to do like a generic lifetime, but that's not happy either. Is it not in here, but rather in here? No, okay. Yeah, explicit lifetime required for this get mute. Do I need to give it? So box mute T. Is it not in here, but up there that I need to give it? So we have this update location system. We might have to give it a lifetime. We might not. Now it's saying that location get mute. So that's off of here. I wonder if I need to give like a instead of like this point, if this is where I need to give it the lifetime. Or do I need to be more like SPECS and create a struct for the system and do that? So let's try that. I'm going to try restarting this just a second. So I want to do a struct. I'm not calling it. So, okay, struct update Annotations system. If we just now impl update location system. Now, this is where I'm probably going to need to use like lifetimes and the generics and all that stuff. This is where we have like a hub function. Do like update location systems. That's fun. And then I do this entire thing. So mute self. Oh, and this is where then we pass in the world. World. Which has this T in it. Well, yeah, so we need the type argument for here. Okay. Now if we do that, then over here, we need to have a T. Okay, it's not constrained by an impl type. Okay, so then I think I can do a where t is, in this specific case, we know exactly what this t is. It's going to be it's a reference, well, actually it's the world, right? So we don't know what that is. It's like this world t. It's got this component. So can I say that? Probably not, because it needs a type argument too. We could do the standard core. Oh, do you need to be up there? No, okay, so. Or do I just care about you being like a tuple of F32? And that's all I'm really caring about. I think I may need to like spend a little bit more time reading through like hex, sort of like understand what's going on with that. So expected trait found, yeah. Because if I come up here and look at your like this any plus debug, and it's not working for us. So standard format debug, like, so if I use this one, so your T is just standard format debug. That's all we care about. Let's try you. Standard T bug. Is not constrained by the impl trait self type. Oh, okay, hold on. So struct, you also need to be T. That. And then we need you to be the exact same thing. Let's see, standard. What? Wrong number of type arguments, expected 1, found 0. Wait, I gave you a type argument. Generic. Or do I just do that? Parameter T is never used. Right. Oh, well, I'm using it right here. Do you not care about this then? Expected 0. Well, now, okay. Hold on. Do I want to put you here then? T, where T is standard format debug. Can I find T in this scope? So that would be here, right? No, so that's the one at the beginning of the impl. Then it doesn't want this one here. And now it's saying, like, it's that constraint problem again. So I'm like back, like in a loop where like, hey, here's a constraint. It's like, no, wrong place to put the constraint. So I don't know enough about like the generics and types, unless like I do some kind of like dine with it to make it happier. But oh, that really doesn't like that. Oh yeah, it's super unhappy now. Unless like the types I can say no, because it's like the world that this is for. So I don't know. I'm gonna have to like figure out. I think it's 12:30. I need to go have lunch. I think what we need to do is like do a little bit more research, figure out how like Hex is doing its stuff, and then I can come back and like actually like get this going. So maybe tomorrow morning what we could do is like use Hex in something like really basic, and then after that we can delve into Hex's source code to figure out how they're doing it a little bit more deeper. So I'll be back tomorrow morning for that. It should be around 7 a.m. Mountain Time. I will tweet and well, let's see. I'll tweet out and I'll like start a little bit early from that, like around 10 minutes beforehand. So if you follow me here on Twitch or follow me on Twitter, you'll get those notifications. Let's see. I don't see anybody that I particularly want to raid right now online. So I think I'm just going to end it right here. I'm going to switch over to the ending screen. Oh, there it goes. Ending screen. All right. Thank you again so much for stopping by. Thank you, Mr. Halsey, again for the raid. And if you stayed with the raid, thank you so much. I already mentioned to follow and do all that stuff. So with that, I hope that you have a great rest of your day, and I hope to see you tomorrow morning. Have a great Sunday. Bye.